Hello, welcome to Thursday. Today we're going to talk about something called combinations. Similar to the counting principle the other day, we're basically using it to find out how many different ways something can happen. But essentially with this one, what we do is we have a set pool or a set number of objects to choose from, like, the pairs of socks in your drawer. And we're going to select out some or all of those things, and the order doesn't really matter. So, if I say, hey, go to your, sock drawer and pick out your 3 favorite pairs of socks, there might not necessarily be an order to that, which you pick them out. You're just going to pick out the ones you like in random order. So, again, that's the idea here. So, the formula, which looks awful, but it's really not that bad. All right, so first off, we have this big giant C here, and that is letting us know that this is a combination. Tomorrow we're going to learn about its cousin called the permutation, where we're going to use a big P. All right, now the little letters off to the side, first the N to the left-hand side. N is the number of total objects that you're choosing from. So again, let's say there's a class of, right now there's probably like 6 of you in the room. So a class of like 6 people, and I need to select a couple of people to help me go carry some boxes up from the front office. Now, I don't care what order I select you in. I just need a couple of kids to come get me some stuff. So the N is the number of people you have or number of options you have to select from. And then the R here is the number of objects you're actually choosing. So, there's 6 kids in the room, and I need, 3 kids to go help me carry some boxes. So the number of things you're choosing. So not everything is getting chosen is the point. And then there's this formula, which again is a little bit ugly. But we learned about factorials yesterday, and they're pretty easy. So I think once you see 1 or 2 of these worked out, they'll make a little bit more sense. All right, so let's do that. Let's go try one. It said there are 4 kids in a family, and their mom needs 2 of them to help bring in the groceries. How many different ways can she choose the 2 kids? So if I was doing this the slow and awful way, I could number the kids like kid 1, kid 2, kid 3, and kid 4. And I could have kid 1 and kid 2. Those could be the ones I chose. But kids 2 and kid 1, different order, but the same 2 kids. So that doesn't count, because the order doesn't matter. It doesn't matter which kid I choose first and which kid I choose second. They both got to come do the same darn job. So that wouldn't count. So I could also have the 1 and the 3, and then the 1 and the 4. Those are some combinations. And then I could also have the 2 and the 3 together, and then the 2 and the 4. Or I could have the 3 and the 4 together. And I think that's all the different pairs. There's 1, 2, 3, 4, 5, 6. 6 ways. Well, that's the long way, especially if you have more than 6 people. What if you have a class of 35 and you need to select 11 of them? I mean, that would be forever to do it that way. So again, these combinations are set up to help you do this. All right, so we're going to use a C for combination, and then there are 4 total kids in the family, and we are selecting 2. So the formula in the numerator is n factorial, and again, in this particular problem, my n is 4, and my r is the 2. So in the top, I get n factorial. That's 4 factorial. And then in the bottom, it's r factorial. And then a parentheses, n minus r, which would be 4 minus 2 factorial. So let's clean that up a little bit. So the denominator, I got a 2 factorial I'll be keeping. And then parentheses first. 4 minus 2 makes 2. So that becomes another 2 factorial. So now I'll expand. In the numerator, 4 factorial means take 4 and go all the way down to 1. In the denominator, I have this 2 factorial, which means start with 2 and go down to 1. And then another 2 factorial, which means start with 2 again and go down to 1. Now let's multiply across the numerator. 4 times 3 times 2 times 1 is going to end up giving me 24. And then the denominator, 2 times 1 times 2 times 1 makes 4. And that reduces to 6. There are 6 different ways that the mother can choose 2 kids to help her. 6 different combinations. Well, let's try one more. A pizza restaurant offers 8 different toppings. How many different combinations of 3-topping pizzas could be made? No double toppings. So, again, they must have a coupon or something. My wife loves coupons, so we would definitely be getting from here if there was a coupon for 3-topping pizzas. We want to know how many different styles of toppings of pizzas we can make. Well, again, making a list of this would be ridiculous, especially since I know what the answer is. It would take forever. All right, so instead we're going to use this combination. And again, there are 8 items. We're choosing 3. All right, so a combination of 8, choose 3. My n is 8, and my r is 3. Right, so the numerator, I want the n factorial, so that's 8 factorial. And then denominator, I want r factorial, and then n minus r factorial. So let's clean that up. The denominators, everything's good except that parentheses. I need to minus the 8 minus 3 first, which would make 5. So now I'm going to expand this all out. It's going to get a little messy. That's why I'm trying to keep the numbers kind of small. Alright, so the numerator, I got 8 factorial, so that's 8 all the way down to 1. All multiply. Well, that's a terrible 1. All multiply. In the denominator, we got a 3 factorial, that's 3 all the way down to 1. And then a 5 factorial, that's 5 all the way down to 1. Alright, let's cancel out the things that match. Match, 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 match. And what's left? Well, in the numerator, we got 8 times 7 times 6, which makes 336. The denominator, we end up with 3 times 2 times 1, which makes 6. Divide those out, and there are 56 different ways, or in this case, not necessarily ways, 56 different pizza combinations. And that's a lot of different possibilities. Okay, this is what you're working on today, and again, tomorrow will be something similar with a slight twist. All right, good luck. Let me know if you need any help.